Hi, my name is Shahroz Ahmed, and in this video I'm going to discuss the concepts of probability. My main focus will be on the exam related questions, so let me just give you a brief overview of the probability formulas and the essential conditions that we should know about the basic probability. So let's start off with the topic. So probability is basically finding the chance of an event. For example, let's suppose we roll our dice, and on a dice there are 6 numbers: 1, 2, 3, 4, 5 and 6. Then we want that 3 should come onto the dice. So if we want 3 should come onto the dice, it means there is only one 3 on the dice. So there is only one possibility of 3, but the total possibilities or the total outcomes are 6. So from this concept we can derive our formula for the probability, that says that probability is equal to the possible outcomes of an event divided by the total outcomes of an event. So the possible outcomes is only 1, and the total outcome of this event is basically the rolling a dice. So the total outcomes of this event are 6, the possible outcome is only 1. So getting a 3 onto a rolling dice, we will get the probability equals to 1 over 6. Okay, now let's discuss another scenario. Now we want that when we roll a dice, then okay, we will roll the dice for 2 times. We want that first time 3 should come, and when we roll it for the second time 5 should come. So what is the probability that we will get 3 in our first try and 5 in our second try? Okay, so let's find it out. So we want 3 in the first try and 5 in the second try. So the probability will become equal to, the probability of getting a 3 in the first try is 1 over 6, and the probability of getting a 5 in the second try is also 1 over 6. But over here we have given a must condition that there must be 3 in the first try and there must be 5 in the second try. So whenever there is such a must condition, in that case we multiply the probabilities. So we will multiply these probabilities and we will get 1 over 36. So the probability of coming 3 in the first try and 5 at the second try will be 1 over 36. Alright, now let's discuss another scenario. Now we want, when we roll dice for 2 times, then 3 and 5 should come. The order does not matter. Maybe 3 should come for the first time or 5 should come for the first time, it doesn't matter. But we want number 3 and 5 on the dice. Okay, alright, so let's work out the probability for getting a 3 in the first try. So that is 1 over 6. Let me just write for the first event. When we roll a dice, the probability of getting a 3 is 1 and the probability of getting a 5 is also 1. So our possible outcomes should be 2 and our total outcomes are 6. So either 3 come or 5 come. So it will be like 2 over 6. Now in the second event, the same should be the possibility, the probability. Either 3 should come or 5 should come. So in the second event we will have 2 over 6. Now in this case we'll multiply it, so it'll be like 2 over 6 times 2 over 6. We will get 4 over 36, that will be equal to 1 over 9. So in this case our probability will increase to 1 over 9. So remember, when there is a must condition we will multiply the probabilities, and when there is an either or condition then we will add the probabilities. So in this one I have added the probabilities like this: 1 over 6 plus 1 over 6, that made it 2 over 6. Similarly over here I added the probabilities of 3 and 5, that is 1 over 6 plus 1 over 6, that made it 2 over 6. So this is how we will get the probabilities for the essential events and for the conditional events. So I think for the basics this is enough. You'll get to know the more concepts when we do the questions. So let's head on towards the exam related questions for the probability. Alright, so here we have an exam related questions related to the probability. It says Bill has some counters in a bag. 3 of the counters are red, 7 of the counters are blue, the rest of the counters are yellow. Bill takes at random a counter from the bag. The probability that he takes a yellow counter is 2/7. How many yellow counters are in the bag before Bill takes a counter? So let's suppose like we have 3 red, 7 blue, and let's suppose we have X yellow counters. And we know that the formula for the probability is the possible outcome over total outcomes. So let's suppose we want to find out the probability of a yellow counter. So the probability of yellow counter, I'll write it as P bracket Y, that says probability of the yellow counter. P of 5 will become equal to possible outcomes over total outcomes. So the possible outcomes are X because they are X yellow counters, and the total outcomes will be 3 plus 7 plus X because they are total 3 plus 7 plus X counters. So we can write it as X over 10 plus X. And we know that the probability of the yellow counter is 2/7. So it will be like 2/7 equals to X over 10 plus X. Now we'll do the cross multiplication. So in the cross multiplication we will get 7X equals to 2 times 10 plus X. So it will be like 7X equals to 20 plus 2X, and I'll subtract 2X on both sides, so I'll get 5X equals to 20. So my X will become equal to 4. So we have 4 yellow counters. That's the answer. Now let's move on to the next part. So let me just erase it. Well, in fact we are done with this question. So let's do another type of questions for the probability. Alright, so let's move on to another probability question. It's an exam related questions about the Venn diagram. So we have been given a universal set that has odd numbers less than 30, so like 1, 3, 5, 7, 9, 11 up till 30, and we have the elements of set A that are 3, 9, 15, 21, 27, and for B we have 5, 15, 25. Now in part A it says that complete the Venn diagram to represent this information. So what we do is we will put these elements into A and B. So I'll name this circle as A and I'll name this circle as B. So whatever are the common, I'll write it here, and whatever are uncommon, I'll write over here and here. So let's just choose the common ones. So as we can see over here we have only 15 as common, so I'll write 15 over here, and then in A I'll be left with 3, 9, 21 and 27, and in B I'll be left with 5 and 25. Now all the remaining ones that are odd numbers but less than 30, that will be outside this A and B. So 1, 3 is there, 5, 7 is not there, 9, 11 is not there, 13 is not there, 15 is there, 17, then comes 19, then 21 is there, 23 is not there, then we'll have 25, so 25, so this one is 25, and 27, we have 27, and 29 is not there. So these are the elements that will be outside the set A and B, and these are inside. So this is how we'll complete our Venn diagram. So with the help of this Venn diagram we'll be able to find out the probabilities in the next part. So let's move on to the next part. Alright, so in this part it says a number is chosen at random from the universal set. What is the probability that the number is in set A union B? So we have to find out the probability that the number will be in A union B. So for A union B it means that the number should be inside A and B. Like our numbers should be these ones. So these numbers are inside A and B. So let's count the numbers and let's count the total numbers. The total numbers that we have are 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So for the probability our total outcomes are 15, and the possible outcomes are the ones that will be in set A and B. So we have 1, 2, 3, 4, 5, 6 and 7. So we have 7 numbers in set A and B. So the probability will be 7 over 15 for part B. So this is how we'll work out the probability using the Venn diagrams. Now let's see another question where we find out the probability by using a table. Alright, so here we have a question in which we have been given a table. It says the two-way table gives some information about how 100 children travel to school one day. So this row is representing the boys, this row is representing the girls. These columns are representing the mode of travel. So 15 boys walk through to the school, and there are a total of 14 boys that go to school. There are a total of 54 boys, and we don't know about the car, we don't know about the girls who go by walk. So I'll make it as X, I'll make this as Y, and this is as Z, and this is as A. Now we have to complete this two-way table. So as we can see that the total number of boys are 54. So the Y will be equal to 54 minus 15 minus 14. So this is how we can find out the value of Y. So let me just calculate it. So that would be equal to 25. So we'll have 25 over here. Now 25 plus 8, that will be equal to 33. So 33 will be here, and 15 plus X should be equal to 37. So we will have 17 over here, and 17 plus 8 plus 16 should be equal to Z. So I'll just add them up and we'll get the number over here. So it equal to 41. So we will have 41 over here. So this is how we'll complete this two-way table. Alright, now let's see part B. It says one of the children is picked at random. Write down the probability that this child walked to school that day. So we will see the children who are going to school by walk. So there are 37 children who go to school by walk, boys and girls combined, and the total children are 100. So the probability will become equal to the possible outcomes over total outcomes. So the possible outcomes are 37 because there are 37 children who go to school by walk, and the total are 37. So the answer will be 37 over 100, or we can say 0.37 will be the probability. So this is how we can find out the probabilities by using the Venn diagrams or the tables. Now let's see the questions where we have to find out the combined probability. Alright, so in the combined probabilities, I would like you to show the question related to the tree diagrams. So we have a question. It says Louis makes a spinner. The spinner can land on green or on red. The probability that the spinner will land on green is 0.7. Louis spins the spinner twice. So complete the probability tree diagram. So there are two events. This is the first event and this is the second event. So in the first event we got the green color. The probability of getting a green is 0.7. Now the probability of getting a red will be equal to 1 minus 0.7 because the sum of all the probabilities is equal to 1. So if the probability of green is 0.7, so the probability of red should be equal to 0.3. So we'll get 0.3 over here. Now similarly over here it says the probability of green is 0.7, so the probability of red is 0.3. Over here the probability of green is 0.7, so the probability of red will be equal to 0.3. So this is how we can complete our tree diagram. Remember that the sum of all the probabilities is equal to 1, so that's why I have written 0.3 over here, and because there was 0.7 over here. Now let's move on to part B. Alright, so in part B it says that work out the probability that the spinner lands on two different colors. So we have to find out the probability where the spinner will land on two different colors. So let's move back onto the tree diagram. So for two different colors, so we want green with red, and we want red with green. We do not want green and we don't want red. So in order to find this probability we will do it like this. So in the first spin we want green, in the second spin we want red. Okay, so this will be the case, plus if in the first spin we get red, then in the second spin we want green. So this is the second case. So what we do is we'll find out the probability of green and times it with the probability of red. So we'll get green red, and then we'll work out the probability of red and times it with the probability of green in the second spin, we'll get the probability of red green. Now we'll add both the probabilities, because both the probabilities is supporting our outcome, because we want two different colors. So the working will go like that: green red, that will be equal to 0.7 times 0.3 plus red green, that will be equal to 0.3 times 0.7. So this will become equal to 0.21 plus 0.21, and our final probability is equal to 0.42. So the probability of getting two different colors is 0.42. So this is one way of doing this question. There are other ways as well, but right now I want to restrict myself up to only one method. Alright, so let's see another question. This is a hard level question. So let's see how it goes. It says Caroline has 20 biscuits in a tin. She has 12 plain biscuits, 5 chocolate biscuits, and 3 ginger biscuits. Caroline takes at random 2 biscuits from the tin. Work out the probability that the 2 biscuits were not the same. So there are two events. The first event is that when she picks up the first biscuit, and the second event is when she picks up the second biscuit. So for that purpose, I think I have to make a tree diagram. So let's make the tree diagram for this situation. So there are 3 events. Now plain, chocolate, and ginger. So plain, chocolate, and ginger. And for this one, another 3 events. So another 3 outcomes: plain, chocolate, and ginger. For this one, another 3 outcomes: plain, chocolate, and ginger. For this one, plain, chocolate, and ginger. So this will be considered as the first event, this one, and this will be considered as the second event. So let's see the probability of getting a plain biscuit at the first try. So the plain biscuits are 12 and the total biscuits are 20. So the probability will be 12 over 20. To getting a chocolate biscuit, it will be like 5 over 20. The probability of getting a ginger biscuit will be 3 over 20. Now because now one biscuit has been picked up, so the total biscuits in the tin are now 19. So our total outcomes in this case will be 19. Now in the second attempt, let's suppose the probability of the plain biscuit will be equal to, because one plain biscuit has already chosen, so the remaining plain biscuits will be 11, and the total biscuits will be 19. So it will be 11 over 19. For the chocolate, there are 5 chocolate biscuits and the total are 19. For the ginger, there are 3 and the total are 19. Similarly for this one, the plain biscuits are like 12 over 19. For chocolate, now one chocolate biscuit has already chosen, so the remaining chocolate biscuits are 4, so it will be like 4 over 20. I'll just write it in bigger words, so it's be like 4 over 20. So the plain are here. Alright, so the next one for the ginger, it will be like 3 over 19. This is 19 over here. Now for this one, the plain will be 12 over 19. The chocolate will be 5 over 19, but the ginger will be 1 less, that will be equal to 2 over 19. So this is the tree diagram, and now we want to find out the probability that the type were not the same. The type should not be the same. So what we do is we will find out the probability for the same type, and then from 1 we will subtract that probability. So we'll get the biscuits of different type. So right now I'm going to find out the probability for the biscuit with the same type. So it will be plain, so that will be 12 over 20 times 11 over 19 plus chocolate, that will be 5 over 20 times 4 over 19 plus ginger, that will be 3 over 20 times 2 over 19. So this is the probability of the same biscuits. We will subtract that probability from the 1 and we'll get the probability for the biscuits that are not of the same type. So I'll just do a quick calculation and I'll put all of these numbers into the calculator and get the probability. Alright, so the probability that I got is 79 over 190. That is the probability of the biscuits that are of the same type. Now biscuits not same, the probability will be equal to biscuits not same. So their probability will be equal to 1 minus the answer, that is 79 over 190. So I'll get 1 minus answer will be equal to 111 over 190. So in decimals, if you write down in decimals, it will be 0.584. So the probability for the biscuits being not same is 0.584, and this will be our answer. Remember that our probability should be from 0 to 1, and if it's in percentages, it's from 0% to the 100%, and the sum of all the probabilities is equal to 1. So our answer is 0.584. This is the probability that the biscuits will not be same. So this is it for all of these questions for this whole topic of probability. I hope you got the concepts. Thank you.